Dear students, in this video series, I am solving question 3, Roman number 1, 2 and 3 of exercise 1.3. If you want to revise or watch the answer of preceding exercises or questions, please click the I button or go to the link given in description below. Okay, let us read question number 3 first. It says, prove that the following are irrational number. Roman number 1, 1 by root over 2. Roman number 2, 7 root over 5. Roman number 3, 6 plus root over 2. In my last video series, I had explained the term rational number and also exemplified the numbers like root 2, root 3, root 5, root 6, root 7, root 8, root 10 are irrational number, as the number under roots are not perfect square. On the basis of this concept, we are going to solve the question number 3. Okay, now let us come to the solutions. Let us assume that 1 by root 2 is rational number. Then 1 by root 2 is equal to p by q. See, I have already explained you that rational number. Rational number is equal to p by q. That means we are taking in the form of p by q, where p and q are integer and q at the denominator and q at the denominator is not equal to 0. So we need to remember that on this basis p and q are rational number now. So let us take root 2 up. Then we can reverse the system of number that q will go up and p will come down as we are taking root 2 up. So now here, since q by p are integers, q by p is a rational number. Then root 2 is also rational number, which is not true. Thus our assumption that 1 by root 2 is rational is wrong. Hence 1 by root 2 is irrational number. And our complete answers look like this. Okay, now let us move to solution Roman number 2. Let us assume that 7 root 5 is a rational number. Then 7 root 5 is equal to p by q. Now let us see that I have already defined rational number. Rational number is equal to p by q, where this p and q are integers, and the number at denominator q is not equal to 0. Now on this basis of definition, we have already got 7 root 5 is equal to p by q. Now let us come to next step. Let us write root 5 here, and then let us write p here, and q should be multiplied with 7, that is 7q at denominator. Now since p by 7q are integers, then p by 7q is a rational number. Then root 5 is also rational number, which is not true. Thus our assumption 7 root 5 as a rational number is wrong. Hence 7 root 5 is an irrational number. Please read the statement properly, then you will understand this. Let us move to Roman number 3 solutions. Let us assume that 6 plus root 2 is a rational number. Then 6 plus root 2 is equal to p by q. As usual, I explain you that rational number is equal to p by q, where p and q are integers and q at the denominator is not equal to 0. Let me keep aside this one. So let us simplify this one. We have to write 6 has to be taken on the right side. So let us write root 2 here and p by q. 6 when we bring on the other side, it becomes negative. Now let us do simplification. Root 2 is equal to q. We will write p here and then we will multiply with 6, that is 6q. Since p minus 6q and q are integers in p minus 6q by q, then p minus 6q by q is a rational number. Then root 2 is also a rational number, which is not true. Thus our assumption that 6 plus root 2 is a rational is wrong. Hence 6 plus root 2 is irrational number. Remember this, rational plus irrational will give you irrational. Rational into irrational will give you irrational. Rational minus irrational or irrational minus rational will give you irrational. Rational divided by irrational or irrational divided by rational will give you irrational. Rational into rational is always rational, but irrational into irrational is not always irrational. Okay children, I'm signing out for this video series. I'll be coming up with new solutions of new exercise in the next video. Till then, take care. And don't forget to have a regular practice, as mathematics requires a maximum amount of practices to improve your skills. Thank you for watching Ask Me Anything. Please do like, share and subscribe to support my channel Ask Me Anything. Your one subscribe will give me a new platform of teaching. If already subscribed, then thanks for your subscription. And press the bell icon to get interesting questions and latest updates.